sections of the brain, and then model what behaviors result to try to determine what parts of the brain control what types of behaviors. The problem with those past technologies has been that they are limited in terms of space, how precisely they can control a specific tiny neuron, which is microscopic, and the delay that would occur between the stimulation of the neuron and the observable behavior that might change as a result of the stimulation, activation, or inhibition. Some of the common methods have been electrical stimulation, for example. So temporally, it's quick response, but spatially, it can't target an individual neuron. So it's limited. The optogenetic technology is able to do that. And it's completely reversible, like a light switch. It can be turned on and off. And the way Karl has done this is why they call it opto, light activated. Well, where does the genetics part come from? That's what stumped me. Karl is able to do this by reaching into biology and starting with the algal cell that we mentioned in the very beginning. There are certain types of algae that are photosensitive, and he's able to take DNA from one of those algal cells, insert it into a benign virus, implant that virus very precisely into a neuron of the brain, and that makes the neuron photosensitive. And then using a thin fiber optic, like a strand of human hair, in experimentation with mice, which is the animal that's most widely used, he's able to implant the fiber optic and turn the light on or off and measure very precisely and instantaneously what change occurs in the behavior of the mouse. Now I'm going to turn it over to Dr. Koo. Would you like to come up, Dr. Koo?
Okay, thank you for your invitation. I think Dr.
Please, feel free to use the microphone. And let me introduce you more properly. Dr. Leon T. Xuan Koo. Please give us a technical explanation and correct my superficial understanding.
Okay, I just try to use simplified words to explain this, why it's important for this innovation. Because for almost this recent 100 years, from today to 100 years ago, our technology to research or to realize how our human brain function or the behavior, there's no any breaking through technology for people to realize how our brain works. So until Dr. Karl Deisseroth, his strategy was, how can we just use the protein from algae? So the protein, which is the light sensitive protein, which can responsive to the light. So he simply just clone the protein and implant the protein, light responsive protein, into a mammalian cell, which the model is a mouse neuron model. So in this case, we can just simply use light to shine on the neuron cell or even the mouse brain to activate when the mouse eat or running or do anything. So in this case, so we can better understand how the animal, do anything or control the animal to do whatever we want. So, and more important, I think this technology, because for the previous technology, we thought that's inventive technology, which people always use like electricity to stimulate the neuron. But for this technology, we don't use electricity anymore. We use the light, just like Jade mentioned previously. We can simply use the light, like the red light or the blue light, to shine on the cell and activate it. So this is why Dr. Karl Deisseroth got the Kyoto Prize 2018 for the advanced technology. Thank you very much.
Thank you.